There is a virus on Earth that you cannot fight off once it reaches your brain. It has been with humans for over 4,000 years. And the strangest thing about it is not how it kills you. It is how it makes you behave on the way. We mistook it for werewolves. We mistook it for vampires. We mistook it for demonic possession. For most of human history, we could not see what was actually happening. We could only see what it did to people and animals, and we built stories around what we were seeing. What was actually happening was a virus. Rabies lyssavirus. Bullet-shaped, 180 nanometers long, carrying exactly 5 genes and 12,000 bases of RNA, less information than a short text document. And in those 12,000 bases, evolution wrote one of the most precise behavioral hijacks ever documented in biology. By the end of this video, you will understand why every classic symptom of rabies, the rage, the foaming mouth, the famous fear of water, is not a side effect of the disease. It is the strategy. Let's start with the bite. The moment a rabid animal's tooth breaks skin, the virus is already inside the new host. But not in the bloodstream. That would be a mistake. The bloodstream is patrolled by the immune system, by white blood cells, by antibodies. The virus does not use the bloodstream, it enters muscle, and for a few days, nothing visible happens. In those first few days, sometimes up to a week, the virus is doing exactly one thing, replicating slowly and quietly inside the muscle cells near the wound. There is no fever, no swelling, no alarm. The host, animal or human, has no idea anything is happening. Because the virus is not trying to make the host sick. It is preparing for a journey. The journey starts at a specific point in the body's anatomy, the neuromuscular junction. This is the place where a peripheral nerve meets a muscle fiber, the synapse that lets your brain tell your muscles to move. It is a small, specialized chemical bridge, and rabies has evolved a key for it. The viral surface protein binds to one specific receptor on the nerve, a receptor nature put there for a completely different reason. The receptor is meant to receive acetylcholine, the chemical your brain uses to tell your muscles to contract. Every voluntary movement you have ever made, every step, every breath, every reach, runs through this receptor. The virus uses it as a doorway, and through that doorway, rabies enters the peripheral nervous system. From this moment, the immune system effectively cannot find it. Antibodies live in the bloodstream and tissue fluids. The nervous system is shielded, separated from the bloodstream by the blood-brain barrier, and inside individual nerve cells, antibodies cannot reach. The virus has chosen a location where the host's own immune surveillance is almost blind, and the host has no idea any of this has just happened. The bite, if they remember it at all, was hours or days or weeks ago. The wound has closed. Life continues. Whatever fear they might have felt in the moment of the bite is gone now, because nothing is happening that they can detect. And now the virus begins to climb. What rabies does next is one of the strangest journeys in biology. It travels from the bite site toward the central nervous system, but along the inside of nerves, not through the bloodstream. And it moves slowly, about 8 to 20 millimeters per day. For a bite on the foot, it can take weeks to reach the spinal cord, months to reach the brain. For a bite on the face, closer to the central nervous system, symptoms can appear in as little as a few days. This is why historical records of rabies often distinguished between bites that were lucky and bites that were not, even though in both cases the outcome was usually the same. How does the virus move? Every neuron has internal machinery that moves cargo. Molecular motors, proteins called dynein, walk along internal tracks called microtubules, hauling material from the nerve ending back to the cell body. This is the cell's own internal transport, used every second of your life to ferry molecules, vesicles, and signals back and forth along nerve fibers that can be a meter long. Rabies hijacks it. The virus binds to those motor proteins. The cell carries it. Handoff after handoff, neuron to neuron, the virus climbs the nervous system using the host's own delivery system. The host's body is moving the virus forward. The host's nerves are the highway. The host's molecular motors are the engine. And throughout this long climb, weeks, sometimes months, nothing visible has happened to the host. There is no fever, no symptom, no warning. By the time anything goes wrong, it will be too late to do anything about it. Tension. Dark. What happens when the virus finally arrives at the brain is fast and targeted, and it begins, almost immediately, to do something that nothing else inside a human's head normally does. Pause. It begins to take over the parts of the brain that decide how you behave. Serious. Calm. When rabies finally reaches the central nervous system, the spinal cord first, then the brainstem, its behavior changes completely. For weeks or months, the virus has been slow, hidden, replicating only enough to maintain itself as it climbed. Now, suddenly, it is somewhere new. Warm, surrounded by cellular machinery, surrounded by neurons it can use. Slow, heavy. It begins to replicate explosively. Calm. Inside infected neurons, characteristic structures form. Small, round, eosinophilic bodies called Negri bodies. They are the assembly factories where the virus is being mass-produced. Adelchi Negri, an Italian pathologist working in Pavia, first described them in 1903. He was looking through a microscope at brain tissue from a rabid animal and noticed inclusions inside the neurons that did not belong there. He could not have known they were virus assembly stations. Virology as a field barely existed, but he correctly identified them as the pathological hallmark of the disease, and for almost the entire 20th century, finding Negri bodies in a brain at autopsy was the gold standard for confirming rabies as cause of death. In many parts of the world today, where modern molecular testing is unavailable, that 1903 technique is still in routine clinical use. Serious. But replication is not the most surprising thing the virus does in the brain. Calm. The surprising thing is that it does not infect the brain evenly. Rabies has preferences. It targets, almost specifically, 3 categories of structure. Emphasis. First, the brainstem itself, the part of the brain that controls autonomic function, breathing, heart rate, swallowing reflex. The virus seizes this control center early. Calm. Second, the limbic system, the hippocampus, the amygdala, the structures that govern emotion, aggression, fear response. Rabies preferentially infects these zones. Calm. Third, specific cranial nerve nuclei, the clusters of neurons that control facial muscles, swallowing, voice, the muscles around the throat and mouth. Slow, heavy. Look at that list again. Behavior, aggression, swallowing, throat muscles, pause. These are not random targets. These are the exact systems the virus needs to manipulate in order to spread to the next host. Quiet, dark, and the virus somehow knows where to go. What it does not do, at least not primarily, is spread outward through the bloodstream from the brain. That would expose it to immune response again. Instead, the virus does something that took biologists years to figure out. It uses the nervous system to spread back out. This is called centrifugal transport. From the central nervous system, virus particles travel outward through nerves to specific peripheral tissues. Where the original climb used dynein motors, designed to haul cargo from the periphery to the cell body. The outward spread hijacks the opposite system, kinesin motors, which run cargo the other way. The virus has learned to ride the host's transport network in both directions. But the most important destination, the most strategically important destination, is the salivary glands. The salivary glands are where the next transmission begins. By the time the host shows any neurological symptom, by the time aggression appears, by the time swallowing is disrupted, by the time the famous foaming starts, the virus has already loaded the saliva. There is nothing else for the host to do at this point except deliver it. The body has now been converted into a delivery system. Everything else that happens, every symptom the host is about to develop, is the virus operating the delivery. When neurological symptoms begin, the disease has a name people have known for thousands of years. The animal is rabid. The human is mad with rabies. These descriptions are not metaphors. What we are about to look at is the entire symptom complex of rabies, but with one different question than has usually been asked. Not, what is the virus doing to the host? What is each symptom for? Symptom 1. Aggression. In the furious form of rabies, which accounts for roughly 80% of human cases and most documented animal cases, the host enters a sustained agitated state. Pacing, restlessness, biting at any approaching organism. The biting is not random behavior. It is the central act on which the entire transmission strategy depends. The host bites. The virus moves to the next host. Symptom 2. Hypersalivation. The infected host produces saliva continuously, far more than usual. The salivary glands are full of virus by this stage, and inflammation of the cranial nerves controlling salivation keeps production running. The result is the famous foaming at the mouth. The host produces more saliva than they can manage. Every drop is loaded. Symptom 3. Hydrophobia. This is the symptom that gave rabies its older name, hydrophobia, the fear of water. For thousands of years, observers described it the same way. A person dying of rabies refuses water. They appear terrified of it. But this is not psychological fear. It is mechanical. When water touches the back of the throat, the pharyngeal muscles, controlled by cranial nerves now inflamed by the virus, spasm uncontrollably. The spasm is painful. It feels like choking, like drowning, like the inability to breathe. The host learns fast that attempting to drink is excruciating. They stop trying. But notice what stopping does to the saliva. If the host could drink, could swallow, the saliva would be washed down, diluted, broken down by stomach acid. The virus would lose its delivery system. Hydrophobia is not a side effect of rabies. It is a feature, and it continues from there. Aerophobia, sensitivity to air currents on the face, triggers the same pharyngeal spasm, same effect. Saliva stays concentrated. Restlessness and insomnia keep the host mobile, encountering other animals or humans, increasing biting opportunities. Hallucinations and altered consciousness disinhibit normal social caution. Brief, lucid periods alternating with agitation are partially understood, possibly tied to autonomic instability, possibly to the virus's distribution shifting across affected brain regions. What looks, from the outside, like madness, a tortured animal, a human in agony, irrational behavior, is, from the virus's perspective, an engineered transmission protocol running to completion. Every symptom serves the virus. Every symptom moves it forward. Calm. There is also a quieter version. About 20% of rabies cases, and far more in bats, take what is called the paralytic form. No rage, no biting, just slow, ascending paralysis, starting at the bite site and moving inward, until the breathing muscles fail. This form is often misdiagnosed as something else entirely: Guillain-Barré syndrome, stroke, generic neuropathy. It kills more quietly, but from the virus's point of view, even the paralytic form ends in something useful: a host that lies still, drooling, available to be approached and bitten by curious animals nearby. Slow, heavy. Whether the host rages or lies paralyzed, the virus gets what it needs. Calm. In both forms, the disease moves through the same final stages: coma, autonomic collapse, and, within days, death. The medical outcome is the same: almost universally fatal once symptoms appear. Globally, fewer than 20 people have ever been documented to survive symptomatic rabies, and most of those cases remain controversial in the medical literature. And the host has no idea what they are. But the strangest thing about rabies is not what it does to one body. It is what it has done across human history to the way we understand monsters. Because we have been watching this virus, in animals and in ourselves, for over 4,000 years. And what we were seeing changed what we believed was possible. In 1930 BCE, in the city-state of Eshnunna, in what is now Iraq, a legal code was inscribed on clay tablets. Among the laws were specific provisions for owners of dogs that bit and killed other people. The fine for a vicious dog, known to be dangerous, allowed to roam, was 40 shekels of silver if it killed a free citizen, half that if it killed a slave. These laws are some of the oldest written records we have, and nestled inside them is one of the earliest known references to what we now call rabies, described not as a disease, but as a curse, a contagion, the bite of death. The Eshnunnan legislators did not understand what was killing their citizens. They knew only that some dog bites brought death weeks after the wound had healed, and that nothing could be done. The legal code was the only intervention available: punish the owner and hope it discourages negligence. The Greek word for rabies was lyssa. In Greek mythology, Lyssa was a personification of madness, depicted in classical art alongside rabid dogs. The modern genus name, lyssavirus, carries her name forward. For most of those 4,000 years, we did not know what we were dealing with. We had no germ theory, no virology, no microscopes capable of seeing a virus. What we had was direct observation. We saw what rabies did to animals and humans, and we built mythology to explain it. Look at what we made up. The werewolf. A human bitten by a wild animal, usually a wolf or dog, who becomes infected, gradually transforms in behavior and appearance, and eventually becomes a dangerous biting creature themselves. Bites transmit the curse. The pattern is mathematically identical to rabies transmission. The vampire. A creature with bloody mouth, fear of water, aversion to sunlight, infectious through biting. Some rabies cases include photophobia, extreme sensitivity to light. Some include facial muscle paralysis that exposes the teeth. The cultural template fits. The zombie. A previously normal person, or animal, driven into aggressive, mindless biting behavior. Infectious through that biting. Eventually destroyed by the disease, but spreading it along the way. The leading cultural history hypothesis is that none of these archetypes was originally fiction. They were observations. Pre-virological documentation of what rabies does to a body. We watched a real virus do this to real people for thousands of years, and we wrote the experience into our stories. The monsters in human imagination are largely a memory of what this disease did to us when we could not explain it. This does not mean rabies is the only source of monster myths. Folklore is layered, and werewolves and vampires and zombies have many ingredients: fears about death, decomposition, blood, contagion, the unfamiliar. But across cultures separated by oceans and millennia, one consistent ingredient keeps appearing: the bitten human who turns, the infected creature who infects. That ingredient, more than any other, looks like a memory of this virus. Serious. In 1885, Louis Pasteur changed all of this. He had been working on a weakened form of the virus, growing it in rabbit spinal cords and then aging the tissue to reduce its potency. He believed it might serve as a vaccine, but he had not tested it on a human. Then, a 9-year-old boy named Joseph Meister was brought to him. The boy had been bitten 14 times by a rabid dog. Untreated, he would almost certainly die within weeks. Pasteur was a chemist, not a physician, and administering an experimental treatment was, strictly speaking, illegal under French medical law. He did it anyway. Over 10 days, he gave Meister 13 injections of increasingly virulent virus preparations. The boy survived. Calm. That vaccine, and its modern descendants, is why rabies is now controllable in most countries that can afford widespread dog vaccination. It is also why, despite a virus that has terrorized humanity for 4,000 years, fewer of us are dying from it today than ever before. The World Health Organization estimates roughly 59,000 human deaths from rabies per year, almost entirely in low-income regions where dog vaccination programs are incomplete, almost entirely from dog bites, and disproportionately children. Emphasis. But the cultural memory has not faded. Quiet. Dark. We still write stories about creatures bitten by other creatures transformed by infectious madness, biting to spread. Slow. Heavy. We are still writing about rabies. We just call it something else now. Quiet. Dark. And this is why rabies is the strangest member of the series we have been exploring. In an earlier video, we met a parasite that performed surgery without a brain. We called it the surgeon without a mind. We met a parasite that ran a mother's program without a brain. We called it the mother without a mind. Slow, heavy. Rabies is the third. The puppeteer without a mind. Serious. Same evolutionary puzzle. Each subject smaller. Each more reduced. Cymothoa was an animal. Saccholina became a network of foreign cells inside another animal. Rabies has never had a body, never been alive in any standard biological sense, and yet it executes the most complete behavioral takeover we have documented. Emphasis. 12,000 bases of RNA. 5 genes. No metabolism. No cells. Quiet. Dark. More than enough, evolution decided, to write 1,000 monsters into human imagination. Pause. Less than enough, anyone would have said, before they saw what it did. If you're the kind of person who likes peeking behind the curtain of our eerie, beautiful world, the kind who wants to understand how the smallest things in biology engineer the largest stories in our culture, then this channel exists for you. The deep dives keep coming. The stranger ones haven't even started yet. Subscribe so the next one finds you. We have explored a surgeon, a mother, and a puppeteer, all without a mind. There is one more example coming, and you have probably heard its name. You may even think you already understand it. Most people don't. In the next video, we move from a virus that hijacks animals into spreading itself to a fungus that has been doing the same thing longer, with the same precision. A fungus that does not kill its hosts. It wears them. You will want to see this one.